Hey, good morning everyone from San Diego. This morning we're going to be rewriting trigonometric expressions using sums and differences. So this is useful if we are trying to find the exact value of a degree or radian measure and we don't know, and it doesn't lie on a general unit circle. So if it is the sum or the difference of two values that we do know on a general unit circle, then we can utilize those values that we do know to find the one that we don't. So what that really looks like is, say you have the cosine of 105 degrees, you're trying to find that value. Well, you can break 105 degrees down into either the sum or difference of two values that we already know. And you can see we have our unit circle here, and 105 degrees we could achieve with 60 degrees and 45 degrees. So we'll rewrite 105 degrees, or rewrite this as the cosine of 45 degrees plus 60 degrees. This will be your A value, and 60 degrees will be your B value. So you will then plug those into this formula here to find that exact value. So it's important to note that with the cosine expression here, your operation value is going to flip. So if you are adding A and B to get your initial degree measure, then you're going to be subtracting here. So this is going to flip when you plug it into the formula. With sine, we'll do the same degree measure, 105 degrees. Excuse me, I might have been blocking that. The sine of 105 degrees, what we already know is going to be 45 degrees and 60 degrees. So we can rewrite that as the sine of 45 degrees plus 60 degrees, where 45 degrees is our A and 60 degrees is our B, and we can plug that into this equation for the sine, little difference or sum formula to get that exact value. And note that with sine, this value is going to remain the same. So if we're adding A and B to get that initial degree measure, we're going to be adding here to get that initial degree measure. And then for tangent, we have 5 pi over 12. I'm not going to go over the conversion process, but it equates to 75 degrees. So the most apparent things that you immediately add to or subtract to, well, no, add in this case. 75 degrees is going to be 30 degrees and 45 degrees, which of course falls in quadrant 1. We're using all quadrant 1 values here. So we have the tangent of 30 degrees plus 45 degrees, where 30 degrees is going to be your A value and 45 is going to be your B value, and then you would plug those values into this expression here where we have tangent A plus minus B equals, so on top, note that your operation is going to remain the same. However, so you have tangent A plus minus tangent of B, you put that over 1 minus plus, so just like with cosine, this operation value is going to flip. So if you were adding A and B, you're going to be subtracting 1 minus tangent A times tangent B, or if you were subtracting A and B, you would have 1 plus tangent A times tangent B. And then once you go to your unit circle and find your values for cosine, sine, tangent respectively, and then simplify, you should end up with the exact value of whatever that initial degree measure was. And someone else is covering that topic, so I'm not actually going to go through the process. We're just rewriting these expressions. Yeah, that's it. That's rewriting trigonometric expressions using sums and differences.